So I think of Chapter 6 as two chapters. And actually, I'm going to take a blank page and explain that to you. In Chapter 6, Section 1, we review finding products of algebraic expressions, products. In sections 2 through 4, I believe, we will cover the undoing of multiplying, which is called factoring. So we review multiplying in Chapter 6, Section 1, but then we work on Section 6, 2 through 4, and I'm just checking really quick to see if that is the right sections. I'm pretty sure it is. Yeah, where we're going to factor. And I call that like the first chapter of Chapter 6. And then in sections 5 through 8, we study rational expressions and equations. Those are fractions, but they're algebraic fractions, rational expressions and equations. I kind of call that the second chapter of Chapter 6. So that's kind of where we're going. So the first segment here is just going to be a quick review. I've got to go find this document. Of multiplication. So for example, and actually I'd like to even take a really simple one first. 2 times x plus 4. When you distribute that, you get 2 times x, which is 2x, and plus 2 times 4, which is 8, and you're done. So here, when you multiply 3a squared times 2a, you get 6. Be careful and be sure that you add the exponent. So that's got an exponent of 1. So 2 plus 1 is a to the third. And 3a squared times 7 is 21a squared. When you FOIL, in number 2. So if you need to write all the steps down, that's fine. 3x times 4x is 12x squared. Don't forget the 2 there for squared. Then this term is a positive 15x, and a minus 7 times 4 is a minus 28x, and a minus 7 times 5 is a minus 35. And don't forget that often the middle terms are like terms, so they can be combined together. Those two add to be a negative 13x. Bring down your minus 35, bring down the 12x squared. That's really mostly what we need to know for this chapter, but I'll go ahead and do a few more of these. So I sub 1, I'm just trying to get you to hear subscripts again, plus 4 times I sub 1 plus 4, because I want you to square it. So I want that binomial squared. So I times I is I squared, but it's I sub 1 squared. Then right here, 4 times I sub 1 is that, and another 4 times I sub 1. They'll combine to be 8 in a minute, and 4 times 4 is 16. So you have I sub 1 squared plus 8 of these I sub 1s plus 16, and you have FOILed this. Let's go up here. So FOIL these two binomials. So 1 times 7 is 7. You don't have to rearrange these. 1 times a minus e cubed is a minus 1e cubed. A minus e cubed times 7 is a minus 7e cubed. The reason I put the minus 1 here so that when I combine it with the minus 7, I'll get a minus 8. But this minus times this minus is a positive. 3 plus 3 is 6. I'm multiplying those, but remember their bases are alike, so you add their exponents. So I have 7 minus 8e cubed plus e to the 6th power. I guess if I was going to do number 5, I would go ahead absolutely do what's inside the parentheses first. So 6t times 6t is 36t squared. Remember that when one of these binomials has a minus sign and one has a plus sign, but they look alike, this positive 6ty and this minus 6ty disappear. So what I have then is a minus y squared, minus y times a positive y, which is a minus y squared. And now I want to square that, which means I should write that out 2 times and FOIL it. Oh my, I didn't do this in advance, so I have no idea what 36 times 36 is. Maybe I have it in my notes. I sure do. So 36 times 36 is 1,200 and 96, I believe. I sure hope so. And then t squared times t squared is t to the fourth power. Here you have a minus 36 t squared y squared, and then another minus 36 t squared y squared, and finally at the end, a negative times a negative is a positive y to the fourth. So these two right here combine to be a minus 72 t squared y squared, plus that y to the fourth at the end, and then the 1296 t to the fourth at the beginning, and we're all done. This last one's pretty challenging. It's essentially take x plus 2 plus 3y and take every one of those terms and multiply it by all three of the terms in the second trinomial. So I sometimes will space these all out. So x times x is x squared, x times 2 is 2x, and x times 3y is 3xy. In order to keep track of myself, I'm going to use a different color now. So 2 times x is a 2x, so I'm going to put it right below this other 2x. 2 times 2 is 4, so I'm going to stick it way over here to the right. And 2 times 3y is 6y, and there is no 6y over here. I'm going to use blue now for the last. 3y times x is 3xy, so I'm putting it underneath this one. 3y times 2 is 6y, so I'll stick it underneath this one. And 3y times 3y is 9y squared. I'm almost out of space, but if I finish this up, it looks to me like I'll have an x squared here. 2x and 2x is 4x. 3xy and 3xy is 6xy. I'll bring the 4 down. 6y and 6y is 12y, plus that 9y squared. And yes, that's out of order, and oh well. I'm just trying to refresh you on multiplication. I'm only gonna go to number 8, but if I have the answer to number 7 in my notes, I will give that to you, and that turns out to be L sub naught plus L sub naught times A times capital T minus A L sub naught times T sub naught. I just want to show you that in this architecture problem, I would probably FOIL these two first because they're the sum and difference of like terms. So the capital R times the capital R is a capital R squared, but this minus R times this minus little r times big R is the same as this little r times big R, and they cancel out. And a positive times a negative is a minus r squared, and now that has to be multiplied by half pi. So you could distribute it. You could write the first term as pi r squared over 2. That's half. That's half of pi. And then the next one, pi little r squared over 2. It says, all of these have said to find the products. There's other ways to write this problem. You could have written it as pi r squared minus pi little r squared, all of it divided by 2. That's another way. So this is all an introduction in multiplication so that we can get ready to undo that in our next 3 sections.